Numerous people have questioned whether humanity is the only species found in the vastness of the universe. We have speculated for some time about the possibility of life on other planets besides Earth. Pondering as I look at distant stars, the existence of life in faraway galaxies. Now, that possibility has become a reality. The head of NASA recently made public that something remarkable has been discovered by our most powerful space telescope, the James Webb, an advanced tool for observing the cosmos. Get ready for revolutionary revelations from the most remote parts of our neighborhood in the galaxy, the discovery of the planet Proxima B's inhabitants. This finding could test everything we know. Come along with us as we explore the mysteries that the Webb telescope has revealed and explore the potential impact this discovery of life on Proxima B could have on humanity and space exploration's future. The James Webb Space Telescope, a marvel of modern science, possesses the capability to completely transform our comprehension of the cosmos. With its advanced technology and strategic location in space, it gives scientists access to investigate distant galaxies, stars, and planets in new and extraordinary ways, providing a unique perspective on the cosmos. Even though this may appear to be an overstatement, the technology behind the telescope lives up to its promises. One of the most unusual aspects of its 6.5-meter primary telescope is the Webb telescope's mirror, which exceeds twice the size of the Hubble Space Telescope's primary mirror, a crucial space instrument for exploration over the last 30 years. The Webb can capture, because of its enormous mirror, even the faintest specks of light from the farthest reaches of space, including regions that were once too distant for other telescopes to examine. In the past, science could only speculate about what might be apparent using conventional telescopes. Now, with the Webb telescope, they are able to observe distant cosmic phenomena in stunning detail. In addition to the substantial mirror, the Webb offers a variety of cutting-edge instruments that can detect a broad range of wavelengths of light in the spectrum. One of these tools, the near-infrared camera, UNARCM, is designed to take pictures in the region of the electromagnetic spectrum that is crucial because infrared light can penetrate the dust clouds that block visible light, enabling researchers to peer deeper into space. The high-resolution UNARCM provides astronomers with the ability to closely observe the formation of stars in galaxies. These observations' objective is to investigate the early universe, its first ray of light, the source and evolution of galaxies, and to locate and examine once unreachable exoplanets. The Webb's sophisticated instruments, such as the UNARCM, provide in-depth information about the structure of the universe, shedding light on how galaxies assemble and evolve over time, and helping us understand the forces that form the universe. Another important tool aboard the Webb telescope is the near-infrared spectrograph IRSpec. This instrument plays a very important role by dissecting light from faraway astronomical objects into their component wavelengths. This procedure, called spectroscopy, provides essential data about the speed, temperature, and chemical makeup of these objects. UNARSpec allows scientists to investigate galaxies and stars in greater depth by utilizing the emission and absorption lines in their spectra to identify the chemical elements that are present and comprehend the interactions between celestial bodies. It also helps in understanding the life cycle of stars and galaxies, revealing aspects of their formation, evolution, and eventual death. One of the most important functions of the Webb is studying the light from distant galaxies that has traveled billions of years to reach us. By analyzing the spectral data from these galaxies, astronomers can determine their age, chemical makeup, and various other features, unraveling the enigmatic nature of their development. Another type of instrument, the mid-infrared instrument, MIRI, is important for studying longer infrared light wavelengths, which makes it easier to look at things like dusty planets, stars, and planetary system regions where newly formed stars are emerging. Thanks to MIRI, astronomers can also investigate exoplanet atmospheres, providing important details about their composition, temperature, and potential habitability. The boundaries of space where stars are born are particularly fascinating. These dense clouds of dust and gas, despite blocking visible light, allow infrared light to pass through. Because of MIRI, scientists are able to observe the creation of planets and star systems, analyzing the underlying physical processes that take place in these celestial nurseries. MIRI is also instrumental in identifying exoplanets, as it can detect and analyze the faint infrared emissions from their atmospheres, revealing important information about their surroundings, including the presence of water vapor, carbon dioxide, and various other substances that could provide for life. When looking for signs of biological activity on exoplanets, the Webb telescope specifically makes use of spectroscopy and atmospheric analysis. Even if a planet does not have signs of plant life or oxygen, these elements are not always necessary. For detecting life, spectroscopy, which examines how light behaves when absorbed or released by an object, plays a central role in analyzing exoplanets' atmospheres. When an exoplanet passes its parent star, also called a transit event, the Webb can observe the filtering of the starlight through the atmosphere of the exoplanet. This interaction produces subtle chemical signatures that can be analyzed to identify molecules present in the atmosphere. The Webb makes use of two tools for this purpose: MIRI, which focuses on the mid-infrared spectrum, and NRSPAC, which studies the near-infrared light spectrum. Together, these tools cover a wide variety of wavelengths required for a thorough investigation. During a transit, the starlight moving through the atmosphere of an exoplanet carries information on the chemical makeup of the planet. The Webb analyzes these signals to figure out what makes up the atmosphere, determining which molecules could denote the existence of life or conditions that could support it. By determining distinct spectral signatures, scientists can build models to better understand the planet's atmosphere and climate. One of the main objectives of the Webb is to find biomarkers, substances that are associated with life, such as oxygen, water vapor, and methane. However, the identification of these compounds is only the initial step. Additional observations are required to evaluate the planet's habitability and any biological processes. Another important tool is comparative spectroscopy, which the Webb uses to improve search results. By comparing spectral data from various planets, scientists can draw significant conclusions regarding the potential for extraterrestrial life. What do you think about these findings? Leave your opinions in the section below, and don't forget, if you enjoyed the video, to subscribe and like. I'll see you in the next video. The James Webb Space Telescope's capacity to detect biological markers in exoplanets' atmospheres marks a revolutionary step forward in the search for extraterrestrial life. Its one-of-a-kind combination of technological features makes it possible to observe distant planets with a level of detail that was previously impossible. As scientists continue to study the data gathered from these observations, they are unraveling the mysteries of the cosmos. We are learning new things about the possibility of existence on other worlds. The Webb telescope's capacity to peer into space's farthest reaches permits us to examine the past through the earliest stages of the universe. By capturing light from stars and galaxies the Webb created billions of years ago, offers a rare opportunity to study the evolution of the universe. These observations offer useful clues about the formation of stars, planets, and galaxies, as well as the complex processes that shape the universe as we know it right now. Along with its search, the James Webb Space Telescope for all time is contributing significantly to the advancement of our overall comprehension of space. Its ability to capture detailed images of stars, galaxies, and other distant cosmic phenomena is benefiting scientists who piece together the history of the universe. With each new discovery, the telescope continues to challenge our assumptions about the cosmos and expand the repercussions for space travel, enhancing our comprehension of the possibilities that exist beyond our planet. As we anticipate the The Webb telescope will remain a key tool in exploring the unknown. The discoveries it makes in the coming years could have significant effects, not only for our understanding of the universe, but also for the future of space exploration. As we move forward into space and continue to search for signs of life, the James Webb Space Telescope will undoubtedly be at the forefront of this thrilling journey. In the James Webb Space Telescope as a whole represents a new era in space exploration. Its capacity for observing distant galaxies, detecting exoplanets, and looking for signs of life is a significant turning point in our effort to comprehend the cosmos. With its powerful instruments and unprecedented capabilities, the Webb is poised to change the way that we study space and unlock the secrets of the cosmos. The James Webb Space Telescope's ability to investigate the atmospheres of exoplanets may be one of its most exciting functions, as it allows scientists to look for small clues of life on far-off worlds. The telescope's powerful instruments enable us to observe planets and their atmospheres with an unprecedented level of clarity. By identifying key compounds that could imply the existence of life, like water vapor, oxygen, and methane, the Webb provides a valuable tool for determining whether other planets might contain life. This capability advances beyond simple observations. The Webb's advanced technology helps us make significant comparisons to the planet, allowing researchers to assess how planets with comparable features could potentially sustain life. Through the telescope's ability to perform detailed spectroscopy, it can break down the light from distant stars and planets, offering researchers a snapshot of the chemical makeup of these worlds. This process is crucial for determining whether exoplanets may have environments where life could thrive. And it opens up new research possibilities into the characteristics of habitable areas within the universe. The Webb's ability to also concentrate on the infrared spectrum means it can detect previously hidden objects, like the formation of stars within dust clouds or systems of planets. These locations, where stars and planets are born, are often conventionally hidden from view by telescopes that rely on visible light. However, the infrared capabilities of the Webb give it permission to look through this cosmic dust and reveal details that would otherwise remain hidden. These observations provide a more in-depth understanding of the birth and evolution of celestial bodies, helping scientists learn about the fundamental processes that shape the universe. Moreover, capacity of the Webb telescope to observe in both the mid and near-infrared wavelengths opens up completely new opportunities for studying the life cycles of stars and the development of galaxies. Its instruments are designed to study the light emitted by distant galaxies, stars, and other celestial bodies, allowing researchers to analyze their age, chemical makeup, and structure. Science will benefit from this to better comprehend the evolution of galaxies, how stars get their start and end, and how systems of planets take shape. Another exciting application of the James Webb Space Telescope is its potential to reveal the universe's early stages. By studying the first light galaxies that developed following the Big Bang, scientists can learn more about the very genesis of the universe. This is an important field of study because it can help us understand how the universe has evolved over billions of years and continues to evolve to this day. The strong instruments in the telescope make it possible to examine the past further than previously, capturing light from galaxies billions of years old and providing a glimpse into the beginning of the universe. The data gathered by the James Webb Space Telescope will, without a doubt, have far-reaching implications for the field of space exploration. As scientists continue to analyze the information collected from galaxies, stars, and exoplanets, they will be able to produce new discoveries that put us on the edge of the current comprehension of the cosmos. These findings may alter our approach to thinking about our place in the cosmos, allowing for new inquiries and perspectives for the future of humanity's exploration of space. The Webb telescope is a significant advance forward in our endeavor to investigate the universe and respond to some of humanity's most profound inquiries. Whether it's studying and discovering new exoplanets, distant galaxies, looking for signs of life beyond Earth, the James Webb Space Telescope is enhancing our comprehension of the universe. As it carries out its mission, we can anticipate groundbreaking discoveries that will not only alter our understanding of space, but also our place in it. To summarize, the James Webb Space Telescope is ushering in a new era of exploration. Its advanced instruments and unique position in space make it one of the most effective instruments ever made for studying the universe. From searching for extraterrestrial life to unraveling the unsolved mysteries of far-off galaxies, the Webb telescope is poised to reveal secrets that have long been hidden from our view. As we look toward the future, the Webb's discoveries will, without a doubt, alter our perspective on the universe and where we fit in.